Hello there, my name is Edman, and today I'm going to teach you how a neural network works. So, neural network uh, is the backbone of artificial intelligence. So most of the models out there, such as ChatGPT, DALL-E, Midjourney, DeepSeek, and all these fancy things is built based on neural network. So neural network is just like how human brain works, but we try to do it in an artificial way. Okay, so we try to do it by an actual calculation. That's what's in your network. So it is almost the same architecture. So first things is that you see something. Okay, so let's just take an example. Let's say we want to build a neural network that is capable of recognizing an image, whether it's for a cat or a dog. Okay, so you see an image, you see an actual image, and that is called the input. We give the model the input, we give it an image. Okay, so after that, what you see goes inside the neurons. Okay, a human brain, inside of the human brain, it goes inside the neurons where there is some kind of calculation. Okay, so it goes inside here. Okay, and then your brain tells you, hey, that image is for a cat. Okay, and this is where you decided the animal that is in the image. This called the output. Okay, so the final output is called the prediction of the output. Okay, and this what's where the magic happens inside this layer. It's called the hidden layer. Just call it HIDD. So the input is just a bunch of numbers. That's it. It's just a bunch of numbers. X1, X2, X3, all the way down to Xn. Okay, and so to go from here to here, what we do is we dot product the x with weight. So let's say we set that we want to have a fixed number of neurons. Okay, we have to set a fixed number. Let's say we want 3. So hit layer with n equal to 3 number of neurons. Okay, so 1, 2, 3. Okay, you can do anything. Okay, and again, you can have many hidden layers as well. You can have another 1, 2, 3, and so on. But for simplicity, we will just work with 1. So what we do is we take, for each neuron, we take all these x's, we dot product with weight, and we sum up them together, and we add the bias as well. So don't forget bias 1. So x, we times it with weight. Say weight 1, 1, because we have many neurons here. From here to here, we have another weight. Weight 1, 2. Probably you cannot see this one. We have weight 1, 3, all the way down here. You have weight 1, n. Okay, so x1, where is that thing? X1 times this weight plus x2 times this weight dot product plus this one times this one, all the way down to xn times this weight 1n. Okay, and the final, and we sum up them together, we get this neuron. Okay, and we do this for this neuron again, for the second neuron, and we do it all to all the neurons that we have. Okay, good. And plus, without forget, sorry, I forgot, is that after we sum up all this to each neuron, we plus the biases. get this final value of the neuron. And for this and we do the same again from here to here. So in order to predict this value, we times it again with weight, times it with weight, times it with weight, we plus the biases, okay, and then we get this final prediction. Let's call it y. Okay, let's say we do this, we give it an image of let's say an image of a cat. Okay, so let's just label those classes. Let's say dog represents 0 and the cat represent 0. Sorry, dog represent 1 and the cat represent 0. And this value that has been predicted is equal to 0, which means they say that this image is for a cat, but in fact it is for a dog. So how do we actually teach the model that this image is not for a cat, it is an image of a dog? So this is what we call backpropagation. This is where the model happens. So predicting is called forward pass. Okay, forward pass, and learning and teaching the model is called backpropagate. Okay, so we take the prediction, okay, and we get the correct label. So the actual label, let's just say y hat is equal to 1. This image is an actual dog, but the model predicts that it is for a cat. What we do is we compare them and we try to create to calculate the differences. This is called the loss. We calculated the loss of the y and the actual prediction, and based on this loss, we update these weights. Sorry, I forgot these weights. So these weights and all the parameters, the biases as well, we update them according to this loss. We updated them from here all the way down to this, the final weight here, and this is called the backpropagation. And this is where actually the model learns. So from the input to the output called forward pass, what we do is just we use those parameters to perform the calculation and get the prediction. But in order for the model to learn, we have to do backpropagate. We have to get back to where we were and update those parameters so that it fits, and it says that this is this image is actually not an image of a cat, but rather it's for a dog. And we do this for all the data set that we have as long as we want until the model achieve a good accuracy. Then the model learns. This is how neural network